Now in this lesson we do some work on the graphs of trigonometric functions. Let's look at some examples. The first one, we need to sketch the graph of y equals sine theta for negative 360 degrees, less than or equal to theta, less than or equal to 360 degrees. So there's our number plane there. Our axis there is the theta axis rather than the x-axis this time, and we're going from minus 360 up to 360. Okay, that was our domain. Now let's do a table where we have theta and y. Okay, normally it's x and y, but we're using theta in this case, so theta and y. Now, even though we're using values from minus 360 all the way up to 360, we'll only use the table from 0 to 360. Okay, the reason being is these graphs are very symmetrical. Okay, once we work out what's happening on that side, we can work out what's happening on the negative side as well. Now let's start substituting. Putting 0 degrees in, sine of 0 is 0. Putting 90 in, sine of 90 is 1. Substituting 180, the sine of 180 is 0. When theta is 270, sine of 270 is negative 1. And when theta is 360 degrees, the sine of that is 0. So let's plot some points. There's 0, 0. 90 degrees and 1, 180 degrees and 0, 270 degrees and negative 1, and finally 360 degrees and 0. So at this stage we try to draw a curve as good as we can. Okay, there's no straight lines at all, so you just draw the best curve you can through those points. Now you'll find then on the other side those points, alright, if you work out the pattern of those points, down, up, etc., we will get the same sort of graph on the other side, okay? In fact, it's identical. Now, label of the graph, y equals sine theta. Before we finish off, a couple of things. The height of the graph there, okay, from its center to its highest peak, is known as the amplitude, okay? And the amplitude is 1, okay, the height of the curve from the center. Also, the period is 360 degrees. Now what that means is how long it takes for the graph to repeat itself. So highlighted there, that part of the graph is over a distance of 360 degrees. It repeats itself in the next 360 degrees. And that would continue. So every 360 degrees, the graph repeats itself. Excellent. Our second example now, we need to sketch the graph of y equals 2 cos theta. Again for the same domain, okay, for theta between minus 360 degrees and positive 360 degrees. Well, we start off with our number plane again. There's our axes. A table here, 0, 90, 180, 270 and 360 as we did before. So let's substitute 0 in. 2 times cos 0 is 2. Putting 90 in, 2 times cos 90 is 0. When theta is 180, 2 times cos 180 is negative 2. When theta is 270, 2 times cos 270 is 0. When theta is 360, 2 times cos 360 is 2. So, if we were to plot all of those points, this would be the result. And again, because it's very similar, okay, we do the same on the other side. And then we try to draw a nice smooth curve, okay, our cos curve there. So y equals 2 cos theta there. Again, let's look at the amplitude. This time, you can see it's a bit higher than the previous one, has an amplitude of 2. The period, though, is still the same, okay, it's still repeating itself every 360 degrees. Terrific. Our third and final example for this lesson, we need to sketch the graph of y equals tan theta. This time for theta between 0 degrees and 360 degrees. So our sketch will be a little bit different, okay, only starting at 0 all the way to 360. A table again. Now I've included a couple of extra values on the end there, the 45 degrees and the 135 degrees. We'll get to them. Firstly, when theta is 0, the tan of 0 is 0. When theta is 90, all right, using the calculator, the tan of 90, you actually get an error, okay? You cannot do it. Can't be found. So what we say there, it's undefined. Now, when theta is 180, the tan of 180 is 0. When theta is 270, tan of that is, again, an error. All right, it's undefined. And when theta is 360, the tan of 360, back to 0 again. So, at the moment we haven't got too many points. That's why we chose some extra values here. The 45, the tan of 45 is 1. And the tan of 135 is minus 1. So at last we've got some values other than 0. Now if we plot those 3 points, that's what we had, and that's why we chose some extra points. Not much of a curve happening between those 3 points. We plot these extra points, we get those. Now let's focus on what happens at 90 degrees. Well, because it's undefined, we draw a vertical dotted line through that, known as an asymptote. We're going to do the same when theta was 270 degrees. Now, let's just go back to when theta is 90 degrees. Because we have a problem at that part of the graph, it's good to see what happens around about that. So we're going to choose a couple more values, 89 degrees and 91 degrees, okay? Values very close to 90 degrees on either side. So when theta is 89, we get the tan of 89 is 57.3, okay? A very large number. When theta is 91, the tan of 91, negative 57.3. So let's see. That particular point would be well up there, okay? 89 degrees across, but well up on the y-axis. So the graph then goes up that high. All right, it's going to take off if you like. Gets closer to that asymptote, never actually touches it though. Now when theta was 91 degrees, so just on the right side of that line, y is way down there. It's minus 57.3. So again, the graph is going to look something like that, okay? Going way down, but still never touching that line. Now this part of the graph highlighted will be identical to the part on the left, okay? It'll look exactly like that. And then this part of the graph highlighted will look again like the graph on the left, okay, below the axis. So there's our graph, y equals tan theta. It doesn't have an amplitude because it just keeps on going up, okay, so it doesn't reach a peak ever. However, the period, if you look at it, that is a distance of 180 degrees between 90 and 270. So the period is 180 degrees, okay? Every 180 degrees, the graph repeats itself.